In your worksheet 2, you did not submit some of the questions that one I was asking, like this one. Now you can see question 2A, you did not answer.
Yes, sir.
Why?
স্যার কোশ্চেন থেকে এটা দেখতে হবে স্যার, হতে পারে মিস হয়ে গেছে এইভাবে, লাইক অনেকগুলো আমি যেগুলি পারি না সেগুলি আমি রেখে দেন পরে ওগুলি করার চেষ্টা করি।
2A. Yeah, this one, 2A.
To explain the weight of hammer and by the acceleration are equal. So এটার আনসার আমি জানি, বাট লিখি নাই স্যার।
You know the answer, but you did not write.
Yes, sir. The gravitation weight is actually the mass pulled by the gravitational force towards it, or what? No, I think. Sir, isn't it the gravitational pull is the weight and mass doesn't matter?
Mass does not matter.
Neither does weight. What matters is
if there is no air resistance,
then nothing matters. They will just fall at the same speed.
Fall with same acceleration.
Yes, sir, acceleration.
And it is called acceleration of free fall. In your notes, it's available. I gave one notes, right?
Yes, sir. And sir, I was trying worksheet 3. I did till question 2A. From 2B, I was doing further.
From 2B.
Yes, sir.
So these notes I gave on acceleration of free fall.
Sir, let me just send you the
what do you want to send? This one.
Sir, the worksheet, which I did.
Acceleration of free fall. You have to read this part, especially the last part. This part is giving you the ideas for this question. 2A. Okay, and we have here the other question you answered. Anyway, we are going to now 3. Worksheet 3.
I did this much, sir. I think you got a mail from my side.
What you are saying?
Sir, I did worksheet 3 and I sent you that. Still 2B. I was doing 2B. Till 2A, it's all done. No problem except question 15 of MCQ.
So you gave me an email. In my email.
Yes, sir, that one. Question 15 was actually really confusing.
Okay. Question 15 is confusing. Let's see. Question 15. Question 15. Okay, this one.
Yes, sir.
The answer is, uh, you see the examples
Yes,
given
sir.
here.
Sir, you're lapping. I didn't hear the answer.
Yeah, you see the examples given here.
Yes, sir.
Only
Now it's
one
clear. Everything is clear.
only one example is different here. The other three are similar.
Didn't understand, sir.
Look, on sandpaper rubbing a wooden block. So sandpaper rubbing a wooden block. Wooden block is fixed and you are moving the sandpaper, right?
Forward and backward.
Yeah. Again, you see on the skis of a skier accelerating downhill on smooth snow. So here snow is
The
stable.
object.
Yeah, it's a smooth snow. It is staying over there, but the skier is moving forward, right?
Sir, বুঝতেছি না, sir.
This
Means
one you
আমি
understood.
explanation-টা
B,
বুঝি নাই.
You understood what I said. I said that you have
The
here three
skier is
examples.
moving except the snow.
Mhm. The snow, smooth snow, is in its place, right? But the
Yes,
skier
sir.
is going forward. So here you are getting the similar thing. Like sandpaper is moving. Sandpaper is moving, and the wooden block is in one place staying, right? And here the skier is moving. The smooth snow is in its place, not moving up from its place. Then the last one on the tires of a braking car. On the tires of a braking car. So
The
uh,
surface of the tire is
yeah,
moving. Just
but
the
the
braking.
brake is in its place, right? Brake is
Yes,
not
sir.
moving. At the beginning, you got the example on a suitcase accelerating on a conveyor belt. So here the suitcase is on the conveyor belt.
Not
So
moving, but the conveyor belt is actually moving.
uh, when you are seeing the conveyor belt is moving, the suitcase is on the conveyor belt, right? Isn't it?
Yes, sir.
So when the conveyor belt is moving along with the same speed, the suitcase is also moving. Do you understand what I'm saying? In
Yes,
in
sir.
in airport, what we see that the suitcase we are keeping on the conveyor belt, the acceleration the conveyor belt has, the suitcase also has that, right?
Yes, sir.
So here both the things are moving, right?
But if we see practically, then the suitcase is actually not moving.
Yeah, in the physical appearance, we see that suitcase is not moving.
Suitcase is moving, but
But
actually conveyor belt is moving.
yeah, conveyor belt is moving. So as suitcase is kept on this, and it is also moving with the conveyor belt. Got it? So this example is different. This is the first clue to understand the difference with the other examples. So now we are going to the question. In which example does friction act in the direction of forward motion of the object on which it acts? So in this example, we are getting the friction which is moving forward. The direction of the friction is also moving forward. As the conveyor belt is moving forward, the suitcase is also moving forward along with the conveyor belt. So the friction is also forward direction. Is it clear?
Yes, sir.
Okay, so this one you gave uh, confusing, right? Now it's little bit understandable, right?
Yes, sir.
Okay, so here we are getting other answers. We are checking them that your answer is correct or not. Huh? You will just help me to say your answers. Huh? The option you gave, huh? For one, which one you gave?
B.
Dhaka.
B for Bangladesh.
Okay, B for Bangladesh. Contact forces and weight. Yes, correct. Two,
It's still B. It's still Bangladesh, sir.
yes, correct. Then
Then it's C.
correct. Four,
Four, four is Dhaka, sir.
correct. Five,
Five is D. Still Dhaka.
mhm. Yes, correct. Then six,
Six goes to Bangladesh, sir.
correct. Seven,
Sir, seven is China.
cross.
Why, sir?
You give
Is
China.
it Dhaka?
Yeah, it's Dhaka.
But, sir, the acceleration is towards Dhaka, but it is moving actually like C, means in every point it's moving a bit towards, means towards D, but not actually to D. So shouldn't it be C?
What is the concept? It's circular motion, right?
Yes, sir.
So the resultant force should be working towards the center of the circle. Where is the center of the circle? Where is the center of circle? Hmm? Center of the
Sir, I was
circle
not being able
is
to. Oh,
the
center of the circle. It's towards D.
towards D. So we should choose that one where it is showing center of the circle. Are you convinced? Are you convinced or still you have
Not
doubts?
actually.
Think, then take your time. Yeah.
Sir, I don't know why I still think it's C.
So are
Because
you
it told us the resultant force, sir.
yeah, are
Sir,
they
I think I should see the notes again.
again please? Why you are choosing C?
Sir, I am using a bit of annotate.
So you know that rule, you know that concept that the resultant force should be towards the center of the circle. Are you getting the center towards C? Karim?
The resultant force should be towards the center of the circle.
Yes, resultant force and acceleration both.
Yeah, I was just thinking that I think I am missing something for which I wanted to see the.
Now still you are confusing.
No, sir.
It's okay. D, Dhaka.
Yes, sir.
So you write there cross C, then beside that you write D. You should preserve your mistake also. Okay, Karim,
Yes, sir.
you should preserve your mistakes so that when you will revise, you can quickly revise. For O-level exams, you have to revise, right? Here, 8. Which one you gave?
Sir, let me check. It's Bangladesh, sir.
They are saying about third law, right? So I gave you conditions for having third law and first law. Can you remember that one?
The first law was equal and opposite forces applied, and the third was, I think, opposite to the motion, isn't it, sir?
No, not like that. The first law, in first law, I said the forces are working on the same object. For third law, forces are working on two different objects. Can you remember this one?
Sir, again, please.
In first law, we are having forces. All the forces are working on a single object. In third law, we are having forces working on two objects.
In two objects.
Yes. Yeah. Then you think which one?
Then it's question mark, sir.
Okay, very good. Look at the option B, the one you were saying. You have only
Option
on a
B.
it's only a single object, right?
Sir, it's option B, not option D. B for
Your,
Bangladesh.
your one was B, Bangladesh or Dhaka.
Yes, sir. Sir, B for Bangladesh.
So that one I was saying that Bangladesh, you are choosing that
Sir,
option.
this
Which,
one.
yeah, I understand. So this one you have only one object, a block, right? So it's showing you first law, not
Equal
third
and
law.
opposite. Equal and opposite force.
Yeah, equal and opposite force, and uh, there will be the object can be in rest or the object can be at constant speed. That is first law, but the condition is it's working on a single object. Okay, it's working on a single object. Only one object is there. That is block. The tension, the friction, both are working on a single object. In first one, we are having normal contact force working on the book and the weight also coming from the book. So both weight and normal contact force are.
Sir, sir, it. I just googled the laws and I found that the first law হচ্ছে যে first law of Newton, ঠিক না স্যার?
Mhm.
It says Newton's first law of motion is often stated as an object at rest stays at rest and the object in motion stays in motion with the same speed in the same direction unless acted upon by an unbalanced force. বুঝলাম না স্যার।
Yes, we discussed this one in last. This is the problem when we are discussing. You are not going through the recordings. If you are going through the recording, then it could be easier for you, and we can go forward faster. Okay. That time when we discussed, that time you understood it, but later on you forgot. So first law is about balance force. Third law, it is also about balance force. Only second law is unbalanced force.
Okay,
Is it
sir.
clear?
Balance,
So
unbalance, then again balance.
yeah, we discussed this two law together. You can check the recording. First law as the third law we discussed together, and we gave the similarities. There is similarity there that both of them are working with the balance force. And what is the difference? The difference is in third law we are having two objects, and in first law we are having only one object. Is it clear?
Okay. In B, we are only having one object, so it
In
will not.
A we have only one object. You see the
Sir,
forces
there
are
is table. In A, there is table.
yes,
We need
that
to
is
count that because they have stated it that that is the book, that is the table.
there is
Where
table.
in B, yes, sir,
There
but
is
where
there
in B
is
we have. Okay, sir, you sir.
yeah, there is table, but the forces are coming from the book.
Yes, sir.
Forces are working on the book. So we have the forces for a single object here. Uh, in D,
Okay, the force which in which the force is affecting and in which the object is creating a force is our answer.
you see, forces weight is coming from this book. The weight, this force is coming from the book, and the normal contact force, it is also working on the book. Okay, so the single object book is dealing with two forces. Two forces are working on the single object. That's why it is
So
related to
the
first law.
force which is acting on the book is the third law, and the force the book is creating is the first law, isn't it, sir?
Yeah, you see the
Yeah,
force.
was correct.
Yeah, force we are having here, both normal contact force and weight, they are working on the same object, single object. That's why it's related to first law. Is it clear?
Yes, sir.
And C, you have here two objects. One is electron, another one is nucleus.
Is the proton and the neutron.
Yeah, neutron, they don't have the attractive force. Only the protons they have. However, we are considering the whole nucleus as one object
Okay, sir.
and electron as another object. Then we are having two objects here. Okay, forces are coming from two objects, equal and opposite forces. Okay,
Yes, sir.
equal and opposite forces are coming from the two objects. That's why it is related to Newton's third law. And D, you
It's only
see
the
the,
third law
no, this is first law. Why it is first law? The
because
parachute,
it's not equal opposite. Means it's not equal opposite, isn't it, sir?
no, we are not saying that it's equal or opposite. Maybe it will be equal, maybe it will not. But uh, one thing we understand that these two forces, uh, these
Are
two forces,
being
these
acted
two
by and
forces are
actioned on the
the,
parachutist.
yeah, the two forces are working on the same system, right? When we are
Yes, sir.
considering the weight, then we are also considering the weight of the parachute along with the parachutist, right?
Yes, sir.
Parachute, that one has also some weight. So this parachutist and the parachute along with it, it is a whole system, right? It's working like a single object. So that time, the air resistance we are getting is on the whole system, and the weight we are getting, that is also on the whole system. So it is, if you are considering the forces are equal, also we can say it is first law. Okay, as they did not mention anything, like the forces uh, are unbalanced. They gave us one thing. Each diagram shows two forces they are that are equal in magnitude. So they are saying these two are balanced forces, right?
Yes, sir.
Air resistance, as these two are equal in magnitude. That's why it is balanced for, it is first law, not second law. Is it clear?
Yes, sir.
Okay, so 8 you understand that the answer you gave B, it is cross, and the correct answer is C.
Okay.
Done? Are you convinced?
Yes, sir.
Okay, if you are done, then we can go to next one. Okay, this one, which option? 9. 9, what is your answer?
A problem, sir. I have a problem in this.
You have a problem with this, but you gave answer. You gave your answer. Which one you gave? 9, right?
Sir, there should be.
Oh, you
Yes,
have
sir.
question mark. Question mark.
Yes, sir.
Okay, there is question mark. So it's about the resultant force, right?
Yes,
It's
sir.
about the resultant force. So if it is resultant force, then uh, all of the options we are having either constant speed or stationary.
Yes,
And
sir.
if it is linear motion, that means straight line motion. If it is straight line motion, then according to Newton's first law, the forces should be balanced, right?
Yes, sir.
If it is constant speed or stationary, look here we are having constant speed, and they are saying straight horizontal route. Then we are having uphill, moving uphill constant velocity. This is also linear motion. Again,
Yes, sir.
a car that is stationary, this one is completely balanced. If it is stationary, then we have nothing to say, right? Of
Yes,
course, it
sir.
is. Of course, it is first law. So we are having only this left. Bend. Huh? Here is a clue. If a car is moving around a bend, so bending. If there is bending, then we'll get circular motion, right? This way, you are getting a part of circle, right?
Yes, sir.
And when it is part of circle, of course, it is circular motion, right?
There is a resultant force towards the center of the circle.
So it is moving at constant speed, but it has resultant force. As the velocity is changing the direction, there is acceleration, right? Can you remember we discussed this one? That
Just
though,
few moments
though,
back.
yeah, though there is constant velocity or constant speed, we are having the change of direction of velocity, right? We are having the change of direction of velocity, right? This way. Can you remember we discussed this? Hello,
Yes, sir.
Hari. So as the velocity is changing the direction, that's why we are having acceleration. In linear motion, we are getting acceleration as the magnitude of the velocity changes. Like it was 5 meter per second, now it's becoming 10 meter per second. So there is magnitude change, and that's why we are getting acceleration. But in circular motion, we are not having magnitude change. However, we are having direction
Change in
change.
direction.
And because of this direction change, we are having the acceleration in circular motion. Is it clear? Mm-hmm. Kareem. Is it clear?
Oh, yes, sir. I mistakenly unmuted my mic, and for which I couldn't say
So
enter
can you
clearly.
go to the next one?
Yes, sir. It's China.
9B, Bangladesh, okay? You beside your
Yes, sir.
question mark, you write, you keep the question mark and beside that you write Bangladesh B. 10. Which one you took?
Sir, China.
Uh,
Sir, the reason would be because the direction of the object is changing rather than the velocity or speed.
here you see, at the same time, the ball applies a force on his foot. At the same time, huh? Which
Sir,
time?
sir,
Which
could you
time?
just,
When he
yes, sir.
kicks, when the student kicks a ball horizontally, that time the ball is also applying a force. When he is kicking, that time. Okay, during the contact, right?
Yes, sir.
During the attachment, yeah. When the student kicks the ball is applying a force to his feet. So it's matching with the third law. Every action has equal and opposite force. As he is kicking the ball is giving a force on his foot. Every action has equal and opposite reaction. Foot applies a force to the ball, then ball applies a force to his feet at the same time.
The
So
force of the ball is much smaller than the foot. Sir,
here, look,
sir,
how can you decide that the force is smaller? Is there
sir,
any
because
clue?
after the foot touches the ball and the force has been applied, then the ball will move. It won't happen that the footballer kicks the ball and both of them stays at the same point. The ball will move, for which we will be able to know that the force of the foot was much more than the force of the ball
How can
on
you
the foot.
how can you say that the force you are getting from the foot it is smaller?
So because, sir, we can say that
How can you
the
say that?
so we
Take
can say, but in a different way. Like when the footballer will kick the ball and
is
the ball will move rather than both of them not moving and staying at the same point,
look
or the
what is confusing your mind. That is, uh, it happens if you are kicking the ball after you are kicking. That time you will see the ball is moving on the ground or in the air, right?
yes, sir.
So that time in both cases you are having friction. You are having friction and you are seeing that the ball is becoming slow. The way the ball was coming with the speed, you will see the ball is going with less speed. But we are not dealing with that one. They are dealing or they are pointing to that moment. The moment it was in contact with the foot. The ball was in contact with the foot, not after contact is over. Do you understand what I am trying to make you understand? Huh? What I am
Sir, not
saying
clear yet,
specifically,
not
yeah,
convinced.
like they are mentioning it at the same time. I said you at the same time. The ball applies a force to his feet. The foot applies a force on the ball. In the same time, ball applies a force on his foot. So, can you remember just few minutes back we discussed one thing that in third law we have two objects. Uh, two objects, they are giving two forces, opposite forces. Can you remember that
Yes,
one?
sir. But in that, the nucleus is also pulling the electron, and the electron is also pulling the means,
Yes, yes. And
the nucleus.
now we are having the force from the foot, and again the force we are getting from the ball. Why we are getting the force from the ball? As the foot is giving the force to the ball. So every action has equal and opposite reaction. In that case, the one you said about the electron and proton, right? Electron and nucleus. Let us go there. Here, right? So they are attracting each other, right?
Yes, sir.
So if we don't have any charge here in nucleus, will there be any attraction?
No, sir.
So
What, sir?
here,
So could you repeat?
yeah, I'm repeating. If this nucleus does not have any charge, then will
Yes,
there
sir.
be any attraction?
No, sir.
So here the attraction is responsible for both. As the proton is attracting, that's why the electron
If
is
one of them
attracting.
doesn't have a charge, then nothing will happen.
Yeah. So one is attracting, that's why another one is attracting. Here this condition is working. Is it clear? Hello?
Yes, sir. This is clear.
Okay. And the same way we are saying here, as the foot is giving a force on the ball is applying another force to his foot. So it's matching with the third law. Every action has equal and opposite reaction. So which option
But
is
sir,
matching?
in this, none of the means not the electron, not the proton has a change in radius. Means I'm just trying to explain that there is no change in radius. Means no change in distance between them. They are neutral in that case, but not in this case because the ball is moving, sir. The ball will move far away from the footballer
Yeah,
if he kicks the ball.
we are saying this one that it's neutral, fine, but here we are also getting two forces, right?
Yes, sir.
And
One
one
smaller,
force,
one larger.
yeah, one force is created for another force. If you are not, applying any force on the, if you are keeping the ball beside your leg, beside your foot, will it create any force? Just
No,
you are
sir.
keeping. So why is creating force on your foot? Because you are applying some force.
It's still applying a force to the earth when we didn't, but it's applying still.
So one force is coming for another force. So here we are getting Newton's third law. Are you clear now?
So I don't know why I'm still not convinced because
Hello? Say again what you said. Hello? Karim?
yes, sir. Sir,
Mm-hmm.
you said that it is equal and opposite,
Mm-hmm.
but the ball still moves, which means that the ball has a smaller force than the foot which is producing.
Smaller.
Sir, what is the answer anyway?
Yeah. They are saying, look, uh, at the same time. Huh? At the same time means during the time of contact. When the ball was in contact with the foot. Do you understand this condition?
Yes, sir.
Not after their separation. If you think this way that during the same time, that means during the time of contact, not after the separation. What you are saying is becoming smaller. It will be smaller. Uh, it will become slower if the air resistance is working on it. If the frictional force is working from the ground, that time, right?
Yes, sir.
But we are not talking about that moment. We are talking about the time of contact, when just they are in contact. That moment, the foot is having the same force, equal and opposite force from the ball. So, which one you think it is the correct option? I think you can find now. I want
A.
to I want to have it from you. Yes, now you are correct. You think about this one again, and during thinking, you should uh, think with this condition the same time. If this is working for a while, like fraction of seconds. That moment is happening. We are getting equal and opposite force, not after the separation. Is it clear?
Yes, sir.
Yes. Then 11. 11 you gave
It's Bangladesh, sir.
PNR. Yes, it is correct. How long you can stay in class? 5 minutes more. Hmm?
Uh, we can stay till 8:25. Sorry, sir, 10:25. The timing changed.
Really?
Really, sir. They are
Okay,
having some
then
problems, the
then no
students.
problem. Now you continue with 12. Hey, Amena is also talking, right?
She is in a class, sir.
What class?
It's IELTS, sir.
Oh, she's also doing IELTS class. Okay, 12. She wants to fly. Uh, she's making a hurry, right?
Yes, sir.
She wants to fly quickly.
Yes, sir.
That's why she's doing all these things faster. IELTS. Okay, 12. A man, yeah, which
It's
one need to
C.
see? Yes, yes, correct, correct. 13. And Shailesh. Hmm. Yeah, Karim.
Yes, sir.
For 13,
Sir,
which
it's
one is it?
China.
It's China. How? Can you explain this?
Oh, sorry, sir. It's A. My mistake.
It's your mistake. A. Explain how.
Sir, if both means okay, just let me read the question again.
Yeah, yeah. Read. You have to explain which one you are giving. You have to explain. Otherwise, I will not accept. This one is a tricky question. That's why I am saying to explain.
Sir, stationary means it will stay in its position, isn't it, sir?
Yeah, rest position.
Sir, then it's C.
How? So
Sir,
how?
X and Y are creating means X is forward means towards north and Y is towards east. They will create a force towards northeast means if both of these if we consider them are equal forces then they will move at a angle of 45 degree. So if we create a force from 45 degree opposing the let us take in which the object would move due to x and y. Let us take that as A, force A. If we oppose the force A, we will get force means we need the force Z to equally oppose the force A, and we need to make them equal so that it stays in its point. It won't move anymore.
Yes, your answer is correct. Thank you. Thank you for explanation. Thank you for understanding. Then 14. 14. What is your answer?
Sir, it's still China.
Yes. 15. Already we did. 16.
16 is Bangladesh, sir.
So still it is Bangladesh or it should be A.
Oh, sorry, sir. A.
So cut B and give A. Then 17.
It's D.
Yes. Then 18.
It's still D.
Uh, yes. Correct. 19.
C.
Yes. 20.
20 is B.
Yes. So you are done.
Yes, sir.
Very good. Now structured questions. You did one completely, right? You did one completely, right?
Yes, sir.
One is completely done.
Yes, sir. One is completely done.
So what is the answer of A?
Let me check, sir. Sir, it's 91 Newton.
Yes, correct then.
Sir, then it is in a graph.
Mm-hmm. Yeah, how did you do?
Sir, you need to see the. Okay, sir. Just a second.
Here, right?
Yes, sir.
So the conditions given, her acceleration is constant. At time t1, her acceleration starts to decrease gradually. Until she is traveling at a constant speed in a straight line, gradually.
Sir,
So
should have been
acceleration.
something like this. Means
Mhm.
first like this at a constant, and then like this. Because she said she deaccelerated gradually.
Decrease. They did not say deceleration. They said acceleration decreases. So we are showing here. This is a straight line. Okay, till here it is a straight line. Okay. After
Yes, sir.
this, acceleration decreases does not mean
But sir, they said
deceleration.
gradually. See, gradually.
Gradually, we are doing gradually. You see, and here we are having a straight line. Here we did it gradually. Acceleration decreases. Acceleration decreasing, don't confuse with deceleration. Acceleration decreases means still speed is increasing.
After a speed is zero.
Yeah, speed is decreasing. Speed is increasing, but it's not increasing like before. It's increasing with less ratio. Okay, with less gradient. So it's gradually decreasing means we will have a curve line here which will show uh, you know gradient is becoming smaller, and finally it will become flat straight line. Okay, is it clear to you?
Yes, sir.
Here is the graph, speed time graph for acceleration is decreasing this way.
Sir, may I go and drink some water?
No, don't go.
Thank you, sir.
Yeah, so here we are getting you see the gradient is gradually becoming smaller and smaller, right? It's becoming less steeper gradually. So its acceleration decreases this way. Is it clear now? And what you said, that one is deceleration. Speed decreases. But in acceleration, speed should increase. Is it clear now? Hello?
Yes, sir, I'm back.
Hmm. Now it's clear, this one. So your this part should be corrected, huh?
Should be like this.
Yeah, the one here I'm showing. Yeah, like
Okay, so just let me correct it.
yeah, the one I showed you. This one. You can check it, huh? This one gradually decreasing this part. Okay, done. The graph is done. Hello?
Almost, sir.
You do it. You do it in your ease. You understood it or not? That one I'm asking. You understood it, right?
Yes, sir, I understood it.
Then B2 is fine. B2, whatever you wrote, it is okay. Then 2, right? 2, you state how speed differs from velocity. What you wrote about this? Speed is a scalar quantity, is the rate at which object covers a distance, is measured in distance per time. You do not need to write so much. You just write speed is having only magnitude, no direction, and velocity has both magnitude and direction. That's it. Because we don't have so much marks here for this question, right? Only 1 mark. So you are writing for so many marks, 5, 6 marks. Yeah, B, part B. As it orbits the Earth, the satellite is experiencing an acceleration. Explain in terms of its velocity why the satellite is accelerating. Even today we discussed it. Even today we discussed it. Yeah, Karim. Karim.
Yes, sir, I
Hello.
was making the graph.
You do it later. What I said, you understood. That's enough. You do it in your ease, then send me together, all together. Now you understand it. B, you are struggling, right? B1. Hello.
Sir, 2B.
Yes, 2B1, we are here. This part we already explained even today about the circular motion, right? Satellite is having circular motion, which is orbiting the Earth. Is it? Hello?
Yes, sir.
So, why we are getting acceleration in satellite? Today when we discussed in circular motion, why we are getting the acceleration? Why we are getting the acceleration in circular motion? Hmm? Speed is same,
Why
right?
we are getting a circular motion in a
Why we are getting acceleration in circular motion?
because there is a resultant force towards the center of the circle.
No, 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 no. They are saying in terms of its velocity, you should explain it. You know, velocity is constant, right?
Because both of them are creating a force
No, no, no.
towards each other.
Just today we explained also for circular motion we are
Yes, sir.
getting
It's something like the nucleus one.
no, no, no. We are getting acceleration because the velocity is changing the direction in circular motion, right?
Yeah, I wrote it. I wrote it.
You,
In ninth one.
yeah, yeah, that one.
But
Because the
sir, they
velocity
said that
is,
it is experiencing an acceleration. But
yes,
on that case, it was that it
it is
is
experiencing,
accelerating, but
who
actually is
is,
changing the direction.
yeah, is the velocity is changing the direction. You just mentioned this one. Velocity is constant, but it's changing the direction. Okay, continuously. The the velocity is changing the direction continuously. That's why we are having acceleration. That's why the satellite is accelerating. আম্মুকে বলো যে আপাকে মশা খাইতেছে।
Understood.
Yeah. So this one is done. Then on figure 2.1, draw an arrow starting on the satellite to show the direction of satellite's acceleration. So this one is easier for you, right? You can draw. Did you show the drawing? Hmm?
Where is it, sir? Sir, which question?
2B2.
Oh, sir, I didn't do it yet.
Yeah, only the drawing. You have to here draw. You see this question. They are saying you should draw the direction of acceleration. Ah. Is it clear?
B to draw and starting at the satellite to show the
You
direction
do
of the
drawing later. You do drawing later.
In 2.1.
Yeah, figure 2.1 is this one. You have to draw the direction of acceleration from the satellite
Towards the Earth.
Yeah, towards the earth. That's it. You draw one arrow with direction. Huh?
Sir, in B1, the answer would be the velocity is changing the direction of the
Velocity is changing the direction continuously.
object continuously.
Of the satellite, you write. The velocity of the satellite is changing direction continuously. Here, object is satellite. So this part is over, right? Let's see.
Object continuously.
Day after tomorrow, you have a test on topic 2 and 3, okay?
2 and 3.
Yeah, topic 2 and 3, you have test. And still you have left some questions. Those you send to me, okay? You correct it and again resend me.
Yes, sir.
And I will also check again your topic 2 worksheet. Again, I'll check
Thank
if
you,
there is
sir.
anything. If there is anything still you have mistakes, that we will discuss before the test. Okay.
Sure, sir.
We have a little bit left from worksheet 3 to discuss, and if there is anything left from worksheet 2 also we'll discuss. Then after that we have the test. Okay, on Wednesday.
On Wednesday, day after tomorrow.
Yeah,
On the 12th of
7:30.
August.
7:30. Okay.
Yes, sir. There will be no problem on that day.
Inshallah, there will be no problem. So you do this, the rest part you do by yourself and send it. Okay. Try. And
Sure,
if you have any confusion or anything you don't understand, we'll discuss on Wednesday. Okay.
Okay, sir.
Today till now. Thank you so much.
Thank you, sir.
Okay. Allah Hafiz. Best of luck.
Allah Hafiz, sir. Assalamu alaikum.
Salam.